Good morning, everyone, and welcome to our lecture on the integration of artificial intelligence in research principles and methods, tailored for our course on healthcare management and social sciences. Today, we explore how AI revolutionizes research by enhancing data analysis, predictive modeling, and decision-making in these fields. AI encompasses machine learning, natural language processing, and other computational techniques that enable researchers to process vast data sets, uncover patterns, and generate insights with unprecedented speed and accuracy. In healthcare, AI can optimize patient outcomes. In social sciences, it can analyze societal trends. This lecture will cover AI's foundational concepts, methods, applications, ethical considerations, and best practices, aligning with course objectives to equip you with skills for innovative research. Ethical issues, like ensuring data privacy and mitigating bias, are critical, especially in sensitive areas like patient care or social equity. By integrating AI, researchers can address complex challenges, such as predicting disease outbreaks or understanding social disparities. We begin with the lecture outline, providing a roadmap for exploring AI's transformative role in healthcare and social sciences, setting the stage for a comprehensive understanding. Following our introduction, let's review the lecture outline to guide our exploration of AI integration in research for healthcare management and social sciences. This lecture is structured to provide a thorough understanding, starting with an introduction to AI's role in research, highlighting its ability to enhance data-driven insights. We'll then explore key AI concepts and techniques, such as machine learning and natural language processing, to build a foundational understanding. Next, we'll examine AI-driven research methods, including predictive modeling and data mining, tailored to healthcare and social science contexts. Applications will demonstrate how AI addresses challenges, like improving hospital efficiency or analyzing social trends. A specific example, such as AI predicting patient readmissions, will illustrate practical implementation. Best practices, emphasizing ethical AI use and transparency, will ensure responsible research. Finally, a summary will consolidate key takeaways, preparing you for AI-integrated research projects. This outline ensures a logical progression, aligning with course objectives to develop innovative research skills. Ethical considerations, like preventing algorithmic bias, remain central. The slide sets the stage for our introduction, where we'll define AI's role in research and its significance in these fields. Building on our lecture outline, let's introduce the integration of artificial intelligence in research principles and methods for healthcare management and social sciences. AI enhances research by processing large data sets, identifying patterns, and generating predictive insights, surpassing traditional methods in speed and scale. Machine learning algorithms, for instance, can predict patient outcomes in healthcare or social mobility trends in social sciences. Unlike manual analysis, AI automates tasks like data cleaning or pattern recognition, enabling researchers to focus on interpretation. This drives evidence-based decision-making, informing hospital policies or social interventions in Canada. For example, AI might predict disease outbreaks by analyzing health data or assess income inequality through demographic patterns. Ethical considerations, such as ensuring data privacy and addressing algorithmic bias, are critical to maintain trust in sensitive contexts. AI's ability to handle complex, high-dimensional data makes it indispensable for addressing challenges like care quality or social equity. This introduction aligns with course objectives to foster innovative research skills, equipping you to leverage AI for impactful studies. We'll now transition to defining AI in research, clarifying its scope and distinguishing it from traditional methods. Following our introduction, let's define AI in research to clarify its role in healthcare management and social sciences. AI refers to computational systems that mimic human intelligence, enabling advanced data analysis, automation, and predictive modeling. In research, AI processes large datasets to uncover patterns, such as predicting hospital readmissions or analyzing social inequality trends. Unlike traditional methods, which rely on manual statistical analysis, AI automates tasks like data pre-processing and model building, enhancing efficiency. Machine learning, a core AI component, learns from data to make predictions, while natural language processing extracts insights from text, like patient records or social media. AI complements traditional methods by scaling analysis, offering precision in complex datasets. Ethical practices, such as ensuring transparency in AI models and protecting participant data, are essential to maintain integrity. This definition highlights AI's transformative potential, enabling researchers to tackle intricate issues like healthcare delivery or social disparities. Understanding AI's scope is crucial for designing innovative studies. This slide transitions to key AI concepts, where we'll explore techniques like machine learning to build a foundation for their application in research. Building on our definition, let's explore key concepts in AI-driven research for healthcare management and social sciences. Machine learning involves algorithms that learn from data to predict outcomes, such as forecasting patient recovery times based on health records or employment rates based on education data. Natural language processing enables analysis of unstructured text, like extracting insights from patient feedback in healthcare or social media posts in social sciences. Data mining uncovers hidden patterns in large data sets, such as identifying risk factors for hospital readmissions or social inequality trends. These concepts enable researchers to handle complex, high-dimensional data, providing deeper insights than traditional methods. For example, machine learning might predict disease outbreaks, while data mining could reveal correlations between socioeconomic factors and health outcomes. Ethical considerations, like mitigating bias in AI models and ensuring data privacy, are critical to maintain trust. These concepts align with course objectives to develop skills for innovative, data-driven research. By mastering them, you'll address challenges like optimizing hospital resources or understanding social dynamics. This slide transitions to AI techniques, where we'll delve into specific methods for applying these concepts in research. Following key concepts, let's examine AI techniques in research for healthcare management and social sciences. Supervised learning trains models on labeled data to predict outcomes, like using patient health records to forecast readmission risks or education levels to predict income. Unsupervised learning identifies patterns in unlabeled data, such as clustering patients by symptoms to discover disease subtypes or grouping communities by social indicators. Deep learning, a subset of machine learning, uses neural networks to analyze complex patterns, like detecting anomalies in medical imaging or sentiment in social media text. These techniques enable researchers to process vast, diverse data sets, uncovering insights unattainable through traditional statistics. For instance, supervised learning might optimize hospital staffing, while unsupervised learning could reveal social inequality patterns. Ethical considerations, like ensuring model transparency and avoiding biased training data, are essential to prevent unfair outcomes. These techniques align with course goals to develop advanced research skills, enabling data-driven solutions in healthcare and social sciences. Researchers must validate models to ensure accuracy and fairness. This slide transitions to AI-driven research methods, where we'll explore how these techniques are applied in structured research designs. Following AI techniques, let's explore AI-driven research methods in healthcare management and social sciences. Predictive modeling uses algorithms to forecast outcomes, such as predicting patient readmissions based on health data or employment outcomes based on social interventions. Automated data pre-processing and cleaning streamline research by handling missing values, outliers, or inconsistencies, ensuring high-quality data for analysis. For example, AI can clean hospital records or survey data, saving time compared to manual methods. AI-enhanced experimental designs integrate machine learning into trials, like optimizing treatment allocation in healthcare studies or evaluating policy impacts in social sciences. These methods enhance traditional research by scaling analysis and improving accuracy. In healthcare, predictive modeling might guide resource allocation. In social sciences, it could assess education program effectiveness. Ethical considerations, like ensuring data privacy and transparent model reporting, are critical to maintain trust and integrity. These methods align with course objectives to foster innovative, efficient research designs. Researchers must validate AI outputs and address biases to ensure reliable findings. This slide transitions to predictive modeling, where we'll delve into its application for forecasting outcomes in research. Following AI-driven methods, let's examine predictive modeling in AI research for healthcare management and social sciences. Predictive modeling uses historical data to forecast outcomes, employing algorithms like regression for continuous outcomes, e.g., patient recovery time, or classification for categorical outcomes, e.g., readmission risk. In healthcare, models might predict patient outcomes based on treatment history, guiding clinical decisions. In social sciences, they could forecast employment rates based on education interventions, informing policy design. These models enhance decision-making accuracy by identifying key predictors, such as health metrics or socioeconomic factors. For example, a hospital might use predictive modeling to allocate staff efficiently, while a social study could predict income disparities. Ethical considerations, like ensuring unbiased training data and transparent model outputs, are essential to prevent unfair predictions. Models must be validated using metrics like accuracy or precision to ensure reliability. Predictive modeling aligns with course objectives by enabling data-driven, actionable insights for healthcare and social sciences. Researchers must carefully select features and validate models to avoid overfitting. This slide transitions to automated data pre-processing, where we'll explore how AI streamlines data preparation for research. Following predictive modeling, let's explore automated data pre-processing in AI research for healthcare management and social sciences. AI automates data cleaning and transformation, handling tasks like correcting inconsistencies, imputing missing values, or removing outliers in datasets, such as hospital records or social survey responses. For example, AI can standardize patient data formats across clinics or clean demographic data for social studies, ensuring quality without manual effort. Handling missing values might involve predicting them based on patterns, while outlier detection ensures data integrity. This improves efficiency in research workflows, allowing researchers to focus on analysis rather than data preparation. In healthcare, automated pre-processing might prepare data for readmission studies. In social sciences, it could streamline census data analysis. Ethical considerations, like ensuring transparency in pre-processing steps and protecting sensitive data, are critical to maintain trust. These methods align with course goals by enhancing research efficiency and accuracy, supporting robust findings. Researchers must verify pre-processing outputs to ensure data quality and avoid introducing biases. This slide transitions to AI-enhanced experimental designs, where we'll examine how AI optimizes research structures in healthcare and social sciences. Following automated pre-processing, let's examine AI-enhanced experimental designs in AI research for healthcare management and social sciences. AI optimizes treatment or intervention allocation by using algorithms to assign participants to groups, improving balance over traditional randomization. For example, in healthcare, AI might allocate patients to treatment groups based on health profiles, ensuring comparable groups for a drug trial. In social sciences, AI could assign participants to education programs, optimizing for demographic diversity. AI also enables adaptive designs, dynamically adjusting based on interim results, like modifying dosages in clinical trials or tweaking social interventions. This improves causal inference accuracy, providing stronger evidence for cause and effect relationships, such as treatment efficacy or policy impact. Ethical considerations, like ensuring informed consent and transparent AI use, are essential to maintain trust. These designs align with course objectives by enhancing research rigor and efficiency, supporting evidence-based outcomes in healthcare and social sciences. Researchers must validate AI-driven allocations to ensure fairness and accuracy. This slide transitions to applications in healthcare, where we'll explore how AI addresses practical challenges in healthcare management. Following AI-enhanced designs, let's explore applications of AI in research for healthcare management. AI predicts patient outcomes and risks, such as identifying readmission risks using machine learning on health records, enabling proactive interventions. For example, AI models might flag high-risk patients for follow-up care, reducing hospital readmissions in Canada. AI optimizes resource allocation in workflows by analyzing data on staffing, patient flow, or equipment use, improving efficiency. A hospital might use AI to predict peak demand, adjusting staff schedules accordingly. AI also enhances diagnostic and treatment accuracy, like using deep learning to detect anomalies in medical imaging or recommend personalized treatments. These applications drive evidence-based healthcare delivery, improving patient outcomes and cost efficiency. Ethical considerations, such as protecting patient data and mitigating algorithmic bias, are critical to ensure equitable care. These applications align with course objectives by demonstrating AI's transformative impact on healthcare research, enabling data-driven solutions. Researchers must validate AI models and ensure transparency to maintain trust. This slide transitions to applications in social sciences, where we'll examine how AI addresses societal challenges, complementing its healthcare role. Following healthcare applications, let's examine AI applications in social sciences research. AI analyzes social trends and inequalities by processing large data sets, like census or social media data, to uncover patterns in income disparity or education access. For example, machine learning might identify factors driving social mobility in Canada. AI evaluates policy and intervention impacts, such as assessing job training programs' effects on employment rates using predictive models, informing policy design. These insights support evidence-based social programs, like initiatives to reduce poverty or improve education equity. For instance, AI could predict the impact of a universal basic income program on inequality. Ethical considerations, like ensuring unbiased algorithms and protecting respondent privacy, are essential to maintain fairness and trust. These applications align with course objectives by equipping you to address societal challenges with data-driven solutions, fostering equitable outcomes. Researchers must validate AI outputs and transparently report methods to ensure credibility. AI's ability to handle complex social data enhances policy effectiveness. This slide transitions to an example application in healthcare, where we'll explore a specific case study illustrating AI's practical impact. Following social science applications, let's explore an example application of AI in healthcare research, a model for predicting hospital readmission risks. This study uses machine learning to analyze patient data, such as demographics, diagnoses, and treatment history, to predict readmission likelihood. For instance, a supervised learning model might identify older patients with chronic conditions as high risk, with high accuracy, e.g., 85% precision. These predictions inform targeted interventions, like enhanced follow-up care or patient education, reducing readmissions in Canadian hospitals. The model processes large data sets, identifying patterns traditional methods might miss, improving efficiency and outcomes. Ethical considerations, like protecting patient privacy through anonymized data and ensuring equitable interventions, are critical to maintain trust. The study uses validated datasets and metrics to ensure reliability, aligning with course objectives to apply AI for impactful healthcare research. Transparent reporting of model performance and limitations ensures integrity. This case demonstrates AI's ability to drive data-driven clinical decisions, enhancing care quality. This slide transitions to an example in social sciences, where we'll apply AI to a societal issue, complementing our healthcare focus. Following our healthcare example, Let's examine an AI application in social sciences research, analyzing education and employment outcomes. This study uses machine learning to analyze data on education levels, socioeconomic status, and employment rates, predicting how education impacts income. A supervised learning model might show that additional years of education significantly increase income, with high predictive accuracy. These findings inform policies to enhance education access, promoting social mobility in Canada, such as funding programs for underserved communities. The model processes complex data sets, identifying nuanced patterns, like regional disparities, that traditional methods might overlook. Ethical considerations, like using unbiased training data and protecting respondent anonymity, are essential to ensure fairness and trust. The study uses validated datasets and performance metrics, aligning with course objectives to apply AI for societal impact. Transparent reporting of model assumptions and limitations ensures credibility. This example demonstrates AI's power to provide evidence for policy design, addressing inequalities like income disparities. This slide transitions to best practices in AI research, where we'll explore strategies for rigorous and ethical AI-driven studies. Following our example applications, let's discuss best practices in AI research for healthcare management and social sciences. Using validated datasets and models ensures reliability. For example, a healthcare study might use standardized patient records, while a social science study could use verified census data. Validated models, like those tested for accuracy, ensure robust predictions. Transparency in AI processes, such as documenting model algorithms, training data, and performance metrics, allows scrutiny and replication, maintaining study integrity. For instance, a hospital study should detail how a readmission model was trained, while a social study might explain data pre-processing steps. Ethical issues, like mitigating algorithmic bias and protecting data privacy, are critical to prevent unfair outcomes, especially in healthcare or social equity research. In Canada, ethical guidelines emphasize transparency and fairness. These practices align with course objectives to promote rigorous, trustworthy AI research. Researchers must validate outputs, address biases, and report limitations to ensure credible findings. This slide transitions to ethical considerations, where we'll delve deeper into ensuring integrity in AI-driven research. Following best practices, let's explore ethical considerations in AI research for healthcare management and social sciences. Ensuring data privacy and security is critical, particularly when handling sensitive patient records or social survey data. For example, encrypting healthcare data or anonymizing social responses protects participant confidentiality, adhering to Canadian privacy standards. Mitigating algorithmic bias and ensuring fairness prevents unfair outcomes, like biased predictions in patient care or social policy recommendations. For instance, a model predicting readmissions must be trained on diverse data to avoid favoring certain groups. Transparent reporting of AI methods, including data sources, model algorithms, and performance metrics, ensures accountability and replicability. Ethical practices align with course objectives by fostering responsible research that builds trust and drives equitable outcomes. Researchers must implement bias detection techniques, like fairness audits, and adhere to ethical guidelines to prevent harm. By prioritizing ethics, you'll produce credible AI-driven studies that enhance healthcare delivery and social policy. This slide transitions to AI model validation, where we'll explore how to ensure reliable and accurate AI outputs in research. Following ethical considerations, let's examine AI model validation in research for healthcare management and social sciences. Validation ensures models produce reliable, accurate outputs using metrics like accuracy, correct predictions, and precision, correct positive predictions. For example, a healthcare model predicting readmissions might achieve 85% accuracy, while a social science model forecasting employment could report high precision. Cross-validation, like splitting data into training and testing sets, prevents overfitting, ensuring models perform well on new data. In healthcare, This might validate a diagnostic model across patient groups. In social sciences, it could ensure a policy impact model generalizes across regions. Ensuring generalizability means findings apply beyond the study sample, critical for evidence-based decisions in hospital management or social policy. Ethical considerations, like transparent reporting of validation metrics and addressing biases in training data, maintain integrity. Validation aligns with course objectives by ensuring robust, trustworthy AI research. Researchers must use appropriate metrics and validation techniques to avoid misleading results, enhancing model credibility. This slide transitions to applications of AI visualization, where we'll explore how AI enhances data presentation and research. Following model validation, let's discuss AI visualization in research for healthcare management and social sciences. AI generates automated graphs and dashboards, presenting complex data clearly. For example, AI can create heat maps of patient outcomes in hospitals or interactive dashboards of income trends in social studies, making findings accessible. These visualizations highlight key patterns, like correlations between staffing and care quality or education and employment, aiding decision-making. Avoiding misleading representations, such as distorted scales or selective data, ensures integrity. For instance, a healthcare dashboard might display readmission rates accurately, while a social science graph could show inequality trends without exaggeration. Ethical reporting requires transparency in visualization methods, like documenting AI algorithms used to maintain trust. AI visualization aligns with course objectives by enhancing communication of data-driven insights for healthcare and social policy. Researchers must ensure visualizations align with data and audience needs, maintaining clarity and accuracy. By leveraging AI for visualization, you'll effectively convey research findings. This slide transitions to AI and hypothesis testing, where we'll explore how AI enhances testing research hypotheses. Following AI visualization, let's examine AI and hypothesis testing for healthcare management and social sciences. AI automates hypothesis generation and testing by identifying potential relationships in data, such as hypothesizing that staffing levels impact patient outcomes. Machine learning analyzes complex relationships, like interactions between multiple health or social variables, providing deeper insights than traditional tests. For example, AI might test if a new treatment reduces recovery time in healthcare or if education programs improve employment in social sciences, using advanced algorithms to detect subtle effects. This improves precision in causal inference, enabling accurate conclusions about cause and effect relationships, critical for evidence-based decisions. Ethical considerations, like transparent reporting of AI-generated hypotheses and results, ensure integrity. AI-driven hypothesis testing aligns with course objectives by enhancing research rigor and efficiency, supporting robust findings. Researchers must validate AI outputs and ensure unbiased data to avoid misleading conclusions. By leveraging AI, you'll test hypotheses with greater precision, impacting healthcare delivery and social policy. This slide transitions to limitations of AI in research, where we'll explore challenges in healthcare and social sciences. Following AI and hypothesis testing, let's explore limitations of AI in research for healthcare management and social sciences. Algorithmic bias risks unfair outcomes if training data is unrepresentative. For example, a healthcare model trained on biased patient data might mispredict outcomes for certain groups. Similarly, social science models could misjudge inequality if data excludes marginalized communities. AI requires high-quality, large data sets. Small or incomplete data sets reduce model accuracy, limiting reliability in studies like hospital efficiency or social mobility. Complex models, like deep learning, often lack interpretability, making it hard to explain predictions, which can undermine trust in healthcare or policy decisions. Ethical considerations, like transparent reporting of limitations and bias mitigation strategies, are critical to maintain integrity. These limitations align with course objectives by encouraging balanced, critical approaches to AI research. Researchers must complement AI with traditional methods and validate findings to ensure robustness. This slide transitions to mixed methods with AI, where we'll explore combining AI-driven and traditional approaches for comprehensive research. Following limitations, let's discuss mixed methods with AI in research for healthcare management and social sciences. Integrating AI with qualitative methods combines numerical insights with contextual depth. For example, in healthcare, AI might predict patient satisfaction scores, while qualitative interviews explore patient experiences, providing a holistic view. In social sciences, AI could analyze employment trends, while focus groups reveal barriers to social mobility, enriching findings. This approach addresses complex, multidimensional questions, like improving care quality or reducing inequality, by leveraging AI's scalability and qualitative methods' depth. Ethical considerations, like ensuring consent for both approaches and protecting data privacy, are critical to maintain trust. Mixed methods align with course objectives by fostering comprehensive research designs that balance rigor and nuance. Researchers must integrate methods carefully, ensuring AI and qualitative data complement each other, and transparently report processes to maintain integrity. By combining these approaches, you'll tackle multifaceted challenges effectively, enhancing research impact. This slide transitions to evaluating AI research quality, where we'll explore criteria for assessing AI-driven studies. Following mixed methods, let's examine evaluating AI research quality for healthcare management and social sciences. Quality hinges on model accuracy, e.g., correct predictions and robustness, consistent performance across data sets. For example, a healthcare model predicting readmissions must maintain high accuracy across patient groups, while a social science model forecasting employment should perform reliably across regions. Transparency and reproducibility require documenting AI algorithms, training data, and validation metrics, allowing scrutiny and replication. Ethical and bias concerns, like ensuring fair predictions and protecting participant data, are critical to maintain trust, especially in sensitive healthcare or social contexts. For instance, a biased model could unfairly impact patient care or policy recommendations. These criteria align with course objectives by ensuring rigorous, trustworthy AI research that supports evidence-based decisions. Researchers must validate models, report limitations, and implement bias mitigation strategies to ensure credibility. By evaluating quality rigorously, you'll produce reliable AI-driven findings. This slide transitions to practical applications, where we'll explore how AI informs real-world solutions in these fields. Following research quality, let's explore practical applications of AI in research for healthcare management and social sciences. In healthcare, AI informs delivery and policy by predicting patient outcomes, optimizing resources, or enhancing diagnostics. For example, AI models might guide staffing plans in Canadian hospitals to reduce wait times or inform telehealth policies to improve access. In social sciences, AI shapes equitable interventions, like education programs to enhance social mobility, by analyzing trends in inequality or employment. These applications drive data-driven organizational decisions, such as optimizing hospital budgets or designing fair social policies. Ethical considerations, like ensuring unbiased models and inclusive data, are critical to prevent inequitable outcomes. Transparent reporting of AI methods ensures stakeholder trust and applicability. These applications align with course objectives by demonstrating AI's impact on real-world challenges, supporting improved healthcare and social outcomes. Researchers must align AI models with practical goals, ensuring findings are actionable and relevant. This slide transitions to case studies, where we'll examine specific examples of AI-driven research in these fields. Following practical applications, let's explore case studies in AI research for healthcare management and social sciences. In healthcare, a case study might use AI to predict patient outcomes, like readmission risks, using machine learning on hospital data to identify high-risk groups, informing targeted care plans. In social sciences, A study could analyze education's impact on employment using AI to process survey data, guiding policies to reduce inequality in Canada. These cases demonstrate AI's ability to provide actionable, data-driven insights, surpassing traditional methods in scale and precision. For example, a healthcare model might reduce readmissions by 20%, while a social study could quantify education's economic benefits. Ethical considerations, like protecting data privacy and ensuring unbiased models, are critical to maintain trust and fairness. Transparent reporting of AI methods and validation ensures credibility and replicability. These case studies align with course objectives by showcasing AI's real-world impact, equipping you to design innovative studies. Researchers must validate findings and report limitations to ensure reliability. This slide transitions to our summary, consolidating key points on AI integration and research. As we conclude our lecture on the integration of artificial intelligence in research principles and methods for healthcare management and social sciences, let's summarize key points. AI enhances research by processing large data sets, predicting outcomes, and uncovering patterns, driving data-driven insights for evidence-based decisions. Robust methods, like machine learning, predictive modeling, and automated pre-processing, ensure efficient, accurate research. Applications in healthcare optimize patient care and resource allocation, while social science applications inform equitable policies, like reducing inequality. Ethical practices, such as mitigating bias, ensuring data privacy, and transparent reporting, are critical to maintain trust and integrity. Best practices, like using validated datasets and models, ensure reliable findings. Case studies, such as predicting readmissions or analyzing employment trends, demonstrate AI's transformative impact. These align with course objectives to equip you with skills for innovative, AI-driven research that addresses challenges like hospital efficiency or social mobility in Canada. By mastering AI integration, you'll contribute to impactful, evidence-based solutions in healthcare and social sciences, advancing practice and policy. Thank you for your engagement. This concludes our exploration.